Hello everyone, welcome back to FX021. In this tutorial we're gonna make our smoke shockwave. Okay, so let's get started. The first thing we want to do is of course to get our particles. So let's dive inside, create a node here called pop out, and Ctrl+C to copy it and create our geo folder for our smoke shockwave. So name it smoke shockwave and dive inside, create an object merge here, paste our particles, and we can hide other object here. Now you can see our object particles are here. And when you hover your mouse on the node and click on the node info here, you can see there are lots of attributes here, which we don't need them. It's generated when we do the particle simulations. They got CD, which is color, got age, got that, lots of attribute. So we're gonna clean it. So let's use the attribute delete. And we want to delete every attribute. So use a star here, star here, star here, and star here. So basically delete everything. Now you can see we don't have the blue color on them. And now when you hover your mouse on it, you can see there are only position attributes, okay? Now what we want to do is to create our pyros. So in order for Houdini to create pyro simulations, we need two attributes, density and temperature. So you can use a Rango node, but Houdini already provided us a node called pyro source. Now when you connect it and you choose the initialize to the source smoke, and it will create a density and temperature field here. You can hover your mouse on node info here. You can see we got density, P scale, and temperature. Okay, P scale is particle separation here. So the default value of the density is 1. So you can also create it here using an attribute Rango here. I'm gonna show you how to create using a Rango node. So the density is a float value. So we're gonna use F means float. F at density equals 1. F at temperature equals 1, and F at P scale equals, let me check, 0.1. Okay, this is how you create your own pyro source node. Of course, you can change this to a slider, CHF density scale, and CHF, CH means channel, F means float, okay? Float channel, temperature, and float channel particle scale. And click the icon here, you can create your sliders, okay? Let's set it to 1, set P scale to 0.1. And now when you hover your mouse here on the attribute Rango node here, you can see density, P scale, and temperature, just like what the Houdini creates here, okay? It's the same thing. But we already got the Houdini node, so we're gonna use this one. And now these are just points, so we want to convert that to the volume, okay? So use the volume rasterize attributes here. And also before we convert this to volume, we can visualize our density scales, density value here. When you click on density here, you can see the visualization of the particles here. So click on density, and now you can see they are all the same. They are all white. Why? Because we set the value to 1, so every particle got a density of 1, every particle got a temperature of 1, so they are all same. So we want add some noise on them. So let's create a node called attribute noise and connect it here. So the default is CD. We don't need CD, and we can change it to float because the pyro density and temperature attribute are float. So let's call it density and temperature here. Okay. It's still white. Oh, because we gotta spell it wrong. It's DNSITY, density here. Now you can see we got color here. So change it from positive to 0 center, and you can change the amplitude of it. You can change the element size here. So now you got some more density here, some lower density here. Okay, you can also put some animate noise. So when you play it, it will the noise are animated. Okay, so this is visualization of our density. So now let's turn that off. Now we can convert that to a volume. The attribute we're gonna rasterize is the density and the temperature. Okay. You can lower the voxel size to give more resolution here, and you can lower the particle scale to around 0.1. Let's check. Yeah, pretty good. And you can also change the particle scale here. Maybe still 2, maybe particle separation 0.05. Yeah. Pretty good. Okay. Maybe particle scale 0.3. Yeah, pretty good. And one more attribute we need is our velocity. You can see like we got our velocity here. Let's visualize our velocity. We got our velocity here, but we delete our attribute here, so we lost our velocity. Even we don't delete our velocity, when you convert to pyro and convert to volume, you can see we don't have the velocity field here. So let's put it back here, and we want to transfer our velocity here. So use attribute transfer. So the one we want to transfer here is this, and we want to transfer from our particle here. This one here still got the velocity attribute here. So we want to transfer our velocity to here. So its velocity as a point attribute. So we're going to transfer the point attribute velocity here. So now you can see we still got our velocity here. And we want to rasterize our velocity as well. So let's call it V and visualize this. You can see it's there. So let's merge this two, and let's do our pyro simulation in the DOP network. Okay, this time we're gonna use the DOP network. Let's rename it to pyro DOP, and go to the first frame, and let's put our view flag on it, and let's dive inside. So for you to create a pyro simulation, when you type pyro, you see there is a pyro solver and there is a pyro sparse solver. Okay, there are two solvers for pyro. So we're gonna use the pyro sparse solver here. It's more efficient than the pyro solver. So it's only they only calculate the smoke where they generate, but pyro solver wastes a lot of space. Okay, it's slower. So I think this Sparse solver is updated after Houdini 18, I think, or 18.5. This pyro solver is an old solver, so we don't want to use it. So let's use the Sparse solver. So when you use a Sparse solver, your smoke object also need to be the sparse solver. Okay, it's need to be a sparse smoke object, otherwise that won't calculate. Okay, let's connect here, and let's create a volume source node here. Connect to the third input here, sourcing. Okay, that's basically all we need for pyro solver. So we want to source our source our volume here. So it's our first context geometry here, and you can see here the initialize here is set to source smoke. Houdini got a little bit bug here, like when you the initialize set to source smoke, but there is no attribute here. So you need to switch it to any tab here, maybe sync here, and then switch back to the source smoke. Then you can see it change to density and temperature and velocity here. Okay, that's a small bug in Houdini. So we want to turn on the enlarge field to contain sources. This means like you can see the container here. Like if the first couple frames our volume is up here, the container will not find it. So we want the container find our source. So you can see it automatically resizes the container to include our smoke. Okay, and we want to change the resolution of the smoke. Now it's very blurry, so let's go to the smoke object here, change it to 0.01 and go back to first frame. Now you can see it's more detailed simulation here, and you can see the mushroom shape here, which is the smoke rises too quick. So where you can control that is in the pyro solver Sparse here. You can see the reference temperature here is set to 3000, and the reference temperature is when you hover your mouse on it, you can see the reference temperature is used to calculate the strength of the buoyancy force, and the buoyancy force is the up force. So you need to turn down to around 400, and let's play it again. Now you can see it rises slower than before, but it's still too much. So you can change the buoyancy scale here. If it's -1, then the smoke will go down. Okay? You can see the smoke has go downwards here. So let's change it to 0. We don't want the smoke rise to so let's play. Yeah, I think it's good. We want a shockwave lock, so we don't want it rise too much here. Yeah, I think it's good. So now let's go back to the volume source here. Change the temperature to maybe 0.15 and increase our velocity to 4 maybe. Let's play it. Yeah, I think it's good. And now you need to add a little bit turbulence here. So you can turn on the turbulence here and increase the dissipation here to 0.3 here, and let's play it again. Yeah, you can see the smoke disappear faster than before. And also we want our colliders, so we can let's go to the first frame. Let's go back to the object level. We're gonna grab the shell collision from the sparks. So let's dive inside the pop network here. Let's grab the static object here. This is the shield. So Control C to copy it, and let's go back to our smoke shockwave. And let's go inside dot network here. Control V, paste it, and create a merge node here. Merge this two, and you can turn off the display geometry here. And let's play it. Yeah, now you can see the smoke perfectly on the surface here. I think we can still turn down our dissipation here. I think it's. And let's play it again. I think the turbulence is too much. We can turn down the turbulence. Yeah, I think it's good. You can keep tweaking the value here. I'm gonna pause the video and tweak my value. So see you soon. Hey, I'm back. So I finished tweaking my values here. So my smoke look like this, and you can see it's still not too detailed here. But you know, we can add like they have motion blur in the post, and we're gonna add this glow on our smoke, so it doesn't matter. Like you're not gonna see it. Okay. So let's go back to the sub level here. So when you go back to the sub level, you don't see any smoke in the viewport, right? When you inside .NET, like on frame 24, you see the smoke, but when you go outside, there is no smoke. Why is that? Let's put our view flag on the pyro dot and go to the node info here. You can see no point, no primitive, no vertices, and no field here. Okay. And also I changed the default here is like a star here. Okay, you will see the shield, and you can only export the pyro, so you can do something like this, so it will only export pyro here, but still there's no smoke in the viewport. So we want to export our field, like density field, temperature field, from our dot network. So we're gonna use a node called dot import field. Okay, so the dot network is our pyro dot here. So let's just drag and drop here, and dot node here is the smoke object. The smoke object stores our values. So let's Control C and Control V here, and put our view flag on the dot import field. We still don't see smoke here. It's because we haven't import our field. So you can click the plus icon here and type density. Now you can see the smoke in our sub level. Okay, but let's delete this one. Houdini already provides our presets here, so you can. They have fire, pyro, particles, everything. We're just gonna use the smoke here, and now you can see density, velocity, rest, temperature, and CD. We don't need color. We don't have color on our smoke, and also we don't have the rest field. So we only have density, velocity, and temperature. Okay. And now let's cache our field. So use a file cache node here, connect here, and change it to this, and let's call it $job. $job is the project path, and go to the geo folder and change it to $OS, which is our node name, and $OS. Yeah, this is good. So I'm gonna do a test here. So it's called test 1, And let's copy and paste. This is test 2. And now we're gonna use a pyro post process node here. Okay. First, we got let's change the frame range to single frame. So because we want to do a test here, let's go to frame, let's say frame 24 here, and let's hit save to disk. Okay, now it's saved to disk. Now connect the pyro post process here to the second to the test 2 here, and now let's open our folder, and you can see the test 1 here. You can see the file size here. Okay, and now let's go to the pyro process here. This one is to compress your volume. So usually when you do a smoke simulation, if it's very detailed and it's a large scene, and usually the smoke file, like pyro file, will get huge. So you want to compress your smoke before you save to your disk. Okay, so you can convert to 16-bit float and convert to VDB, basically like turn on everything here. Okay, and now you can change it to single frame and save it to disk again, and you can go to your test 2 folder here, and now you can see the file size here. It's magic, right? And now you can use a switch node to compare these two smokes. Let's connect these two and put our view flag on the switch node here. You can switch between. You can see there is a difference here, but it's not very noticeable, and the file size reduced like a huge amount. Okay, you can see the difference is very subtle. Okay, so always do a pyro post process before you save your pyro simulations. Okay, so we're gonna delete our file cache here. Let's cache it. So I'm gonna delete my folder here. Let's delete it, and let's rename to smoke cache. And you can change it back to frame range and save to disk, and delete the switch node here, and create now here called smoke out here. So that's it for today. So you got all your good looking smoke shockwave here. Okay, see you in next chapter. In next chapter, I'm gonna talk about how do you render all these things out in Mantra. And in my maybe next tutorial, I'm gonna introduce you how to render in Karma. Okay, if you like the video, please hit subscribe and like. Okay, see you in next time.